Hello guys. I want to talk to you guys about um second law of thermodynamics. So the second law states that in a spontaneous process, the entropy of the whole universe increases. And I just want to introduce to you guys an approach to the second law with a bit of maths. So in our simple system, we will just imagine that we have five molecules, and each molecule has available to it a set of energy levels of energies 0, 1, 2, and 3, and so on in arbitrary units. We will also assume that we can distinguish between these five molecules. These assumptions just pretty much won't impact the final results and will make our lives much more easier. So, in the first case, right, seems like I'm using the wrong pen. There are five molecules, and two molecules are in the energy state of 0, 1 in 2, and 2 in 4. So the total energy is just the energy level multiplied by the population of molecules that are in that level and sum it up. So, yep, as shown, the total result is 10, which um, just suits our assumption. And here, I just want to introduce you to W. So W is the ways of how you can um, distribute molecules in different levels. So in this case, there's a formula that we can apply, which is the ways that we can distribute these molecules is equal to the total number of molecules factorial divided by the factorial of populations in each energy level. So in this case, there's a total of five molecules. So factorial of 5 will be on top, and there are two molecules here, and one molecule here. So we plug these numbers into the formula, and our result is 30, which indicates that we have 30 ways to distribute five molecules in this pattern. Right. So let's look at the next example. In this case, there's one molecule occupying each energy level. So the total energy will still be equal to 10 because you just sum them up like this. So it's still our assumption still applies. And in this case, the ways that we can distribute these molecules in this pattern is 5 factorial, which is the total number of molecules, divided by the population in each level. So in this case, there's one molecule in each level. So the number that will be in the bottom is just 1 factorial times itself by 5 times. So it's just 1 factorial to the power of 5. So we plug these numbers in again, and 120 is the final result. So what does it show? It shows that there are 120 ways to distribute the five molecules in energy states like this. And remember that we assume that these molecules are distinguishable from each other. So we really do have 120 ways to arrange them in this pattern. Now, the Boltzmann's entropy formula states that S, which is the entropy, is equal to Kb, which is a constant, multiplied by the natural log of W, where Kb is the Boltzmann constant. And in this case, what is our W? It's 30 and 120. Of course, there are much more ways to distribute the molecules in different energy levels, but we will just choose 2. And remember that in the Boltzmann's entropy formula, when we use W, we want to use the maximum number of W. So 120 and 30, which one is bigger? It's undoubtedly 120. So we would say that W max is 120. So when we apply this formula, we always choose the biggest number possible.